Hi, welcome. In this video, we will solve problem house robber type 2 asked by companies like Amazon, Microsoft, Google, Apple, and Facebook.
Now let's check out one more variation on house robber. Okay, this problem is mostly similar to the last problem that we have solved. Okay, but here is a one variation, and I want you to find out by your itself. But again, like if you are feeling like if there is any struggle, you can just look into this video. Okay, so let's go ahead with the problem statement. So same problem, you are a professional robber planning to rob a house along a street. Each house has a certain amount of money stashed. All this is from here, this is changed. All houses at this place are arranged in a circle, right? So that means they are arranged in a circle. That means the first house is the neighbor of the last one. Meanwhile, adjacent houses have a security system connected and it will automatically contact the police if two adjacent houses were broken into the same night. Given an integer array nums representing the amount of money, return the maximum amount of money you can rob tonight without altering the place. So basically in the last question, right, we were having this array, right, only simple, and we were able to find out the maximum amount of money that we can rob, and we are not allowed to use an adjacent, right? So basically if you are robbing this one, you can't rob this one, then you can rob this one. But in this case, now you can't rob even this one. Why? Because these twos are attached. How these are attached? Basically, now the houses are represented in a circle, right? So if I remove this thing, the first house is at 2, the next house is at 3, and the next house is at 2, right? So if you're robbing this one, right? So then you can't rob this one and you can't rob the adjacent one, right? So you have the only chance that you can rob this. Okay, that the answer will be 2. Okay, if you're robbing this one, okay, you can't rob the next one because again adjacent, you can't rob this one adjacent. Okay, so the only thing is you can rob this one 3 only. Now from 2 and 3, the maximum you are getting, that is 3 only, and that's why the output is 3. Okay, now checks this one 1 2 3 1, right? So I can take 1 and I can take 3. Yes, because that's not the last one, so that's why the output is 4. If I'm starting from 2 and if I'm taking 1, then the output will be 3, which is not maximum than 4. So yes, the answer will be 4 here, right? So the only condition is that previously what we were doing, we were able to take this one and this one, last one, because if they are not adjacent, right, we can take it. If they are not adjacent, first of all. Okay. So here now these two becomes adjacent because the houses are in circle. Okay. So now how we can solve this problem? Any idea, anything, any thought process? What do you think of? So let's create the array first and let's understand how we can create it. Now let's see here examples. So here, right, I can rob this house and then I will not take an adjacent and I will rob this one, and these two are not circally adjacent. So here the answer is coming as 4. Okay. So basically why we are able to rob here the adjacent, because the last one is not basically adjacent to it. It was not the last one, it's not adjacent to the first one because these are in circle, right? So we simply ignored this one, right? We simply ignored this one, right? By say I cancel this one, I simply ignored this one. Okay. But what will happen, suppose if the answer is here instead of 2 there is 20, then what will the maximum amount that you can rob? Then you will take 20 and then you will take 1, you will leave this one, the first one, right? In the second case, okay, are you getting a bit of sense, right, where I am approaching? Let's check this one. Okay, next example. In this array, you can take this one, you can take this one, but you can't take this one. That means the maximum money that you can take, that is 2 plus 9, that is 11. Okay. Now here the maximum money, if you are taking with the second way, that will you will take 7, right? And 3, that you will get 10. Okay, which is maximum, 11 or 10? So 11 is maximum, so the answer will be 11 here. Okay. Now even suppose the value is changed to instead of 1, suppose it's 10, right? If I mention 10 here, 10 here, then still will be the answer same? I guess yes, right? Even if you are starting from 7, right? You will take 3, you can't take 10 because here it's adjacent. And from 2, 9, you can't take 10. So basically here we have ignored completely 10, right? We are finding results still in this array, right? And here we are getting 2 plus 9, that is 11 as maximum. Okay. But suppose here, if instead of 3, it's 30, then I will take the 7 one and the 31. I will simply ignore this one, right? The first, right? Okay. So are you getting a sense that here, let me copy this one. Okay. Here, right? Basically, we can easily find the answer by our last approach that we discussed in house robber. If we are, if we don't have this element, right? I can simply apply my logic till here, right? I can apply my logic that we discussed here, like all the approaches till here, because if I'm not taking adjacent, that means it won't come under circle. I can simply apply the logic here, right? And what I will get as a maximum by this logic, I will get 20, right? My answer will be 20, right? And one answer can be 1 plus 3, that is 1 into 3, that will be 4. Okay, and which is greater? Here 20 is greater. But suppose, because you are ignoring the last one, suppose here we have some thing is 25, then in that case, what we will do? Now you have a 25, okay, and if you are going with this logic, you will get 20 as an answer, maximum answer. But if you think that the maximum answer here should be 20 plus 25, that will be 45, right? So that means you can take till this much and you are ignoring this one, right? So what we will do, what we will do, right? We will first ignore the last element and we will find out the maximum of it. And in the next one, we will ignore the first one and we will find out the maximum of it, right? So if I am ignoring the first one, I will get 45 as an answer. If I am ignoring the last one, I am getting 20 as an answer and I will take the max of it. I will take the max of it. Got it? Okay. Same here. Okay. Let me explain you all this thing. Let's do it from here. Okay. And let's make the values as described. That is, here we have 10, right? So first of all, let's calculate the correct answer, right? The maximum money that you can steal. So that will be 30 plus 7, 37, I guess. Okay. Maximum money. And if you take this path, it will be 10, 9, 10 plus 9, 19, and you can't take 2. Right? Even if you are taking 2 plus 30, that will be 30. Okay. So here we are getting 37. Okay, let's see, are we getting the answer with our logic? So what is in my logic? That I will use the logic basically for this one. I will ignore completely this one. So if I am using my logic till here, I am getting 37. Yes. So by first, by taking 0 to n minus 1, I am getting an answer as 37, right? Now, if I am ignoring this one and I am taking my array from 1 to n, what I am getting my maximum answer. So the maximum answer in that case will be 10 plus 9, 19, right? What I will do, I will take the maximum of it. What is maximum? Maximum of 2, that is 37, and 19. I will get 37. Yes, 37 will be my answer. Now we can apply the same logic in any of the approach. Okay, let's take this case of 232 that we have there. Okay, let me create a size of 232. Moving with this 232. Here we were getting 3 as an answer, right? Okay, so let's see. In the first, I will ignore this one and I will find the maximum of it, right? So here the maximum will be, right, if I am starting from 0 till n minus 1, I will get maximum as 3. Right? If I am ignoring this one and I am applying the logic till here to here, that means from index 1 to n, I will get which as a maximum? 3 as a maximum, right? So here in both the cases, right, I'm getting 3 and 3, so maximum will be 3. Right? You can apply in any of the approaches you want, right? Any of the approaches. Let's take one more case, right? We have 1, 2, 3, right? Here, what will be the answer? If I take the maximum robbery, I can't take 3 and 1, right? If I'm going with 2, I'm only get 2. So the answer will be 3 here, right? If I rob only one house, let's see, will I get the answer with my logic? So first logic, I will start from here to here. I will ignore this one, right? So if I'm ignoring this one, the maximum I will get by 0 to n minus 1 index, I am getting 2. If I ignore this one and if I start from here to here, then what I will get from 1 to n, I will get 3 as an answer maximum, right? What will be the maximum of 2 comma 3? That is 3. Yes, so my answer is 3. Okay. So in our logic, basically in our function, right? What was my function? My function was rob, right? In my rob function, what I will do, right? I will simply say, right, I will create the same function, exactly same function, and I will call with the rob one, right? And I will add the indexes. So basically there was if you can see in the previous, it was nums. Okay, let me show you the previous. So here we were having nums only, right? So what I will do here, we will pass nums, right? But here instead of 0, right here 0, what I will do, I will put this index of g, right? Instead of 1, I will say, because it was for 0, so I will say j plus 1, right? And yes, nothing else. Here we are going till nums.length, that is also constant. So I will say n here, right? And now what I will do, I will simply call basically this rob function with nums. Okay, and there will be I will add two more parameters. So that is will be j and n, because I have added j and n. So I will say nums of rob j will be 0 and n will be nums.length minus 1, right? Second function will be rob nums. I will start from 1 and nums.length, right? And basically I will find the maximum of these two. That will be my answer. Right? Same time complexity, no change in time complexity. Time complexity will be same, right? I am calling this function, right, norms that will take big of n only times, right? Maybe n for this one and n for this one. Yeah, that you can say. So again, even if it is 2n, that is near allowed to be n. What will the space complexity, right? Space complexity will be same big of 1. You are not taking any extra space, right? It's basically you are reusing the function, right? Again and again. Okay. So now let's see. Let me give you a code implementation of this problem. Okay. And then after the code implementation, I guess there is no need of dry run. We can simply move ahead, right? So in the next video, I will give you a code implementation of this problem. Let's see.